Hi everyone. So in this video, we're going to talk about summation notation. Now we're going to start with a very basic explanation of what this term means and then go on to sort of a more complicated example. So the first idea is that this summation notation is a representation of a sum of terms. So what does that actually mean? So over here, we have this ti here. This is a term in general form. Okay, so it's a term, but it's sort of a general expression for a single term. Now this I is basically just a little variable, and it's going to take on a series of values for the sum. Now, over here, the I, you see the I is also present right here. There's an I here as well. So the way that you think about this is that this is basically just like a for loop that starts at 1 and ends at n inclusive. So what this means is that this notation here represents the following: t1 plus t2 plus t3 plus t4 all the way up to tn. So it's the sum of all of these individual little terms. Now, this is sort of an abstract general form of summation. Let's do a more specific example. So let's say that I wrote the following summation notation expression. I start at 1, and I'm going to go to 5 of I. Okay, so what does that actually mean? Well, it means that I replace the I with a 1 or 1, a 2, and then a 3, because you have to keep going up, right? So this would be 1 plus 2 plus 3 plus 4 plus 5. That's what this notation means. I take the variable I and I go up starting at 1, one value at a time, and I add all the things together. So mathematicians for loop that does adding. Now, if I then wrote I is equal to 1 to 5 of the value 5, what would that do? Actually, let's make it a little bit, this might be better, 3. I is equal to 1 to 5 of 3. Now, what this means is I'm actually going to do 3 plus 3 plus 3 plus 3 plus 3, 5 of them. Why? Because even though there's no I here, I still have to have a total of 5 terms from 1 to 5 inclusive. And each time I don't have anything other than a 3, but I have to add them all together. So that's what that actually says. Now, I can also do more complicated ones. For example, like what is this one? I from 1 to n of 2i. Well, in this case, what I would get is I would get 2 times 1 plus 2 times 2 plus 2 times 3 plus, and so on, all the way up to 2 times n. Okay, so that's what summation notation does. It expresses a sum, okay, a series of value, a series basically, right? You're adding up numbers that have a particular pattern to them. So you will see this a lot in some of the proofs. So later on, there will be another video that talks about identities, which is what can you do if you see an expression like this? How can you use it, and how can you simplify expressions of this nature to get to the final result that you actually care about? So in any case, that's it for this video. Thanks.